Hey guys, how y'all doing? In today's lesson, we'll be talking about the domain and range of a linear function. Let's look at some definitions really quickly here. It says a linear function is a relationship with a constant rate of change represented by a graph that forms a straight line in which each element of the input, x, is paired with exactly one element of the output, y. Now, they don't always have to be x and y, but typically we just use x and y's to define it. It could be a and b or etc. But we usually use x and y's. All right, the domain is a set of input values for the independent variable over which the function is defined, aka all your x values. Once again, I put that in quotations because it does not typically have to be x values. It could be any variable values, but mainly pay attention to the part where it says independent variable. Okay, once again, independent means it only relies on itself. It doesn't rely on anybody else. The range is a set of output values for the dependent variable over which the function is defined, aka typically all of your y values. Once again, it doesn't have to be y values, but typically that's what we use. Mostly pay attention, it has to be the dependent variable. This guy usually relies on, or does rely on, a linear function on this independent variable. A continuous function is a function whose values are continuous or unbroken over the specified domain. It does not mean that the function has to go on forever. It just means if I have a set of points, from that point to the other point, you'll draw a straight line without ever picking up your pencil or pen. Okay, this means you can draw without stopping and get to the other side, all right, without having to pick up. So that's continuous. All right, discrete, function whose values are distinct and separate and not connect. Values are not continuous. Discrete functions are defined by their domain. So that's just like if you're plotting some points. If I plot a point here, plot a point in one spot, then have to pick up my pencil or pen and plot it in another spot, and then pick it up again and plot another spot. That is a discrete function. Notice how it's not continuous. All right, some inequality representations. Okay, so we can do like a verbal description. For example, x is all numbers less than 5. The inequality notation, and there's different ways to write this, but we're going to stick with this way for right now. But the inequality notation is x is less than 5. Just we're writing it with symbols. And x is an element, that's what the E stands for right there. That symbol looks like an E, element of the real numbers. X is all real numbers. So we can just write that as x is an element of the real numbers, or all real numbers. Verbal description, y is all real numbers greater than -3 and less than or equal to 6. Writing that inequality notation, just using symbols, we got y is greater than -3, but less than or equal to 6. And once again, y is an element of the real numbers. Another verbal description, y is all integers greater than or equal to 0. So again, writing that with symbols or inequality notation, we have y is greater than or equal to 0. And y is an element of the integers. I know that kind of throws you guys off, and I'll talk about it down here real quick, but note, natural numbers are denoted by the symbol n. Okay, sometimes they write it like this, sometimes just an n. Whole numbers are denoted by the symbol w. Kind of makes sense. This is where those people off integers are denoted by the symbol z. I know you want to write like an I because it seems like everybody else goes with whatever letter they have, but we do write integers with the letter z, or represent integers with the letter z. And real numbers are denoted by the symbol r. Okay, guys. Let's look at the difference between a continuous function and a discrete function. A continuous function is something like f of x or y equals 2x minus 3. And if you graphed it out, it would look something like this. Notice how if I were to draw this line, it would just never pick up my pencil or pen. Once again, it doesn't mean that it has to go on forever. It just means if I draw from one point to another point, I'm never having to pick up my pencil or pen. It's just continuous. For example, here on this other side, discrete function, Notice how we got the x's over here and the y's are aka the f of x is over here. 1's going to 10, so we plot that 1, 10. We got 4 goes to 4. So let's go x is 4, y is 4, plot that point. We got -1 goes to 14, so x is -1, 14 up here, plot that point. And 6 goes to 0. So x value is 6, so go right 6. And you don't have to go up or down because the y value is 0. So plot that point. Notice I was just plotting some points. And notice that if I were to draw this, I'd have to plot that point, pick up my pen or pencil, and plot another point, pick up my pen or pencil, and plot another point, etc., etc., etc. So that is discrete. How we describe the domain and range? Well, this isn't always going to happen on continuous functions, but in this case, I'm going to go ahead and tell you guys, put you on a little secret, that if you're just given the function like this, f of x equals 2x minus 3, you give us some linear function like this without any restrictions, such as it's a word problem that has some restrictions to it, or we're told there's some restrictions, then the domain and the range will always be all real numbers. On this discrete function, the domain we can clearly see is, well, here's our x values, so we got -1, 1, 4, and 6, and we do typically write it in least to greatest order. So -1, 1, 4, and 6. Our range we can clearly see right here as 0, 4, 10, and 14. So 0, 4, 10, and 14. All right, let's look at another example. We've got some continuous functions here. They're both continuous. Again, I don't have to pick up my pencil to draw that line or that one. Okay. So to find my domain, remember it's left and right. Okay, or my x values. So left and right. So it looks like the furthest left I go, if I'm looking at this point, is to -3. The furthest right I go is to this guy right here. And the furthest right he is 8. So, and I can be equal to it. That's what the colored in circles mean. I can be equal. So I am between -3 and 8 and equal to -3 and 8. So domain is all real numbers greater than or equal to -3 and less than 8. So once again, writing that in inequality notation, x is greater than or equal to -3, but less than or equal to 8. And x is, of course, the element of the real numbers. All right, range. We're looking at the range, we're looking up and down. So I like to look at my furthest down I go and then furthest up I go. So furthest down I go is over on this point to the very right. And the furthest down that we go is -5. Furthest up we go is at this point over here on the very left hand side, and it goes all the way up to 6. So we're between -5 and 6, and we can be -5 and 6. So all real numbers greater than or equal to -5 and less than or equal to 6. So y, and once again this is in inequality notation, y is greater than or equal to -5, but less than or equal to 6. And once again, y is an element of the real numbers. All right, looking at this other guy over here on the right hand side, this function. Once again, trying to find my domain and my range. I'm going to first, to find my domain, I'm going to go my furthest left. And I see the furthest left is at this point right here. And it looks like on the very left hand side, and it goes all the way to -8. And then my furthest right I go is all the way over here to this point. And it's at 8. So we're between -8 and 8. Oh, at 8, we can be 8, hence the solid circle. But we cannot be -8. Okay. So my domain is all real numbers greater than -8, because we are always greater than -8, but less than or equal to 8. So once again, inequality notation, we write it as x is greater than -8 or less than or between 8, such as they're the real numbers. See, I like inequality notation because I can put that x down and say I'm between this -8 and this 8, and I'm always greater than that -8 but less than or equal to that 8. Alright, my range up and down, so I'd like to find my furthest down point. Once again, it's over here where this open circle is at. And we see the first down we go is -6. Furthest up we go is at this very right point, and it's to 2. And we can be 2, but not -6. So all real numbers greater than -6 and less than or equal to 2. Once again, inequality notation written down here. Y is between -6 and 2, and we can be equal to 2. And it is the real numbers. All right, another continuous function. We got the function f of x equals 4x. And we see in our graph, we go left to right, we're going up. And it doesn't seem like we can be 0, but that's hence the open circle. But the domain is all real numbers greater than 0 because we continuously go forever and ever and ever. We don't stop. But we have to have a perimeter, so we can't be 0. So domain is all real numbers greater than 0. So x is greater than 0. And my range, well in this case is my perimeter. The perimeter does depend on my length. So perimeter, and once again it goes up forever. Okay. So of course that's all real numbers greater than 0. Once again, cannot be 0, but we continuously go up. Continuously go right and continuously go up forever. So continuously go right, that means our x goes on forever greater than 0, and continuously go up, our y is greater than 0. Okay, we got a discrete function here. It's perimeter in inches of a square created by 1-inch tiles. So you would use kind of the same function f of x equals 4x, but you have to go by increments of 1-inch square tiles. So what that's pretty much saying is we just have to go we got to go over one, our length has to increase by 1 each time because we're using these 1-inch square tiles. So when we go over to 1, we get a 4. When we go over to 2, we get an 8. 3, we get a 12, 4, 16, and so forth forever. Okay. So my domain is all integers greater than 0. Once again, we're using integers now to make our life easier because if I said all real numbers, that means I can be like 1.5. But if I'm saying just integers, then I can only be like 1, 2, 3, 4, 5, 6, and etc. So that's how we use this. So x is greater than 0, and of course x is an element of the integers. Our range, once again, we're going up forever. So we're greater than 0 at all times, but not equal to 0. And y, once again, is an integer as well because we're never like half. Our perimeter is never half or a third or anything like that. It's always an integer. But it's always an integer that's a multiple of 4. So notice that 1 we got 4, and when the x value is 2 we got 8. Notice how the range is going 4, 8, 12, 16, 20. And it's always increasing by a multiple of 4. Or we can just write it as y is greater than 0 or y is equal to 4x. That's pretty much saying y is a multiple of 4 as well. Alright guys, looking at some sample problems here. This one asks, where it says, a function is represented by the set of ordered pairs shown below. What is the domain of the function? What is the range of the function? Well, remember, domain is my independent values, or aka my x values. Remember, our points are written as x comma y. So all these points that we have here, we can easily just find our domain by picking out the x values, which of course is the first digit that's given in the point. So my domain, and once again we do try to keep this least to greatest, and thankfully the way our points are positioned, it does show us least to greatest. So we got -3 first, then -1, 4, then 8, then 14. Okay, my range, of course, my dependent variables, aka in this case my y values. Now we're looking at the next digit that's given to us in the point. So here we got -4. Next we got 2. then 17, then 29, and lastly 47. So there is my domain and my range. Alright, on to the next one. Alright, this one says the domain of the function y equals negative 5x plus 6 is negative 17, negative 6, 3, and 12. What is the range of the function? So this time it gives me the domain, and I'm looking for the range. Okay. Well, I like to make a little chart on this one. Let's see if I can have enough room to do it. My drawing? No, not the greatest drawer. Hopefully I gave myself enough. Alright, so call this my domain members. Go my function. Y equals negative 5x plus 6. And lastly, now give me my range. Okay. So looking at this, once again, it gives me my domain members, my input, or my independent. So it's, when we use the word input, it's because we're going to input this into the x value. So we got negative 17, negative 6, 3, and 12. Alright, so we're going to go y equals negative 5. We're going to input that negative 17. And we're going to add 6. Right. Next we got y equals negative 5 times, we'll input that negative 6 for the x value. Instead of saying x, we're just replacing it with a negative 6 plus 6. Next one we have y equals negative 5. Once again, input that 3 plus 6. And lastly we got y equals negative 5 times 12 plus 6. Alright, we're looking at the first one. Well, negative 5 times negative 17 is 85, and of course adding 6 to it would make it 91. So there's one of my range values. Next one, we got negative 5 times negative 6 makes 30, plus 6 makes 36. Moving along, we got negative 5 times 3 is negative 15. Adding 6 to that would make it negative 9. And lastly, negative 5 times 12 would be a negative 60. And adding 6 to that would be negative 54. So, rewriting it towards us, say my range would be negative 54, negative 9, 36, and 91. Okay. There are other ways to solve. For example, if you have a graphing calculator, just remember negative 5x plus 6. Okay. Alright, real quick, guys. Let me show you what I'm talking about. If we pull out our graphing calculator and go y here, press that y equals button on the top, and then plug in our function negative 5, and press that button right next to the alpha, where you get x plus 6. And then we can hit this second button and go to table. Now there are a lot of other ways, but now you can see you get your x values and it tells you what your y value is here. Tables aren't always great because sometimes we'll have some fractional terms for our domain that we need to find, and it doesn't always go by fractional numbers. Once again, there are other ways in your calculator. You can do a calculation and find a value and etc. But for example, one of our domain members was negative 17. Hence, look, we got that 91 right here. Try to remember another one real quick. Negative 6, 3, and 12. So negative 6. There goes with 36. 3 goes with negative 9. And 12 goes with negative 54. Okay. Just wanted to show you with the calculator by chance you have a graphic calculator with you. Okay, let's look at the next one we got here. This time it's asking, what is the domain of the function y equals 3x plus 6 when the range is negative 6, negative 1, 3, 7, and 10. So now we're looking for the domain given the range. So we can input or we can plug in our range values in for that y value and solve for the x. So I'll show you one way that some students like to go, and then I'll go my route that I usually go. So many of my students will take that negative 6, for example, and plug it in for that y. And they go negative 6 equals, well, now we got 3x plus 6. And then they'll go and solve for that x. So they'll subtract 6 from both sides. Remember, the opposite of adding 6 is subtracting 6. That kills that 6. And negative 6 minus 6 is negative 12 equals 3x. Of course, now we got to get rid of 3, and they're multiplying, so the opposite of multiplication is division. And negative 12 divided by 3 is a negative 4. So there's one of my domain members. Okay, and see, we would have to keep doing that for each and one of these ever values, all these 5. Okay, my favorite route to go is a little bit different, and I'll show you. I'm only going to use algebra one time. That's why I like it better this way. I'm going to solve for x in my function first. So what I mean by that is, once again, I want to get this x by itself. So first I'm going to subtract the 6 over to move the x over on the other side, so I can get the x by itself. And once again, to get rid of a positive 6, we subtract 6. And what we do to one side, we must do to the other. Well, we kill the 6 here. Well, we cannot combine this y and the 6 together because they're not like terms. So we're just going to write y minus 6 equals 3x. Well, of course, my last step to solve for that x to get rid of that 3. And since they're multiplying together, we'll just divide them out. Once again, what we do to one side, we do the other. Kill the 3. And so I get y minus 6 over 3 equals x. Okay, well that helps out now, because now I can just stick in or input my range values into that y. Kind of the same thing I did up above. So I'm going to go ahead and draw another table real quick. Seems to be more helpful to explaining. Mind my drawings. Okay, real quick. Now I got my range member going in first. Got my function, or my new function, as y minus 6 divided by 3 equals x, or x equals. And now my domain member is going to be given to me. Okay, let's see if I gave myself enough space. Probably not. But negative 6. So when I input that negative 6, and for that y, I got negative 6 minus 6 over 3. Okay, we got negative 1. Negative 1 minus 6 over 3. Okay. And I'm going to run out of room, guys, so I'm just going to go ahead and tell you what it is. But if I plug in that negative 6, well, negative 6 minus 6 is negative 12, and negative 12 divided by 3 is negative 4. Next one, and putting in that negative 1, we get negative 1 minus 6 as a negative 7, and we have negative 7 over 3, which is some ugly number because it'll give me negative 2.3333 on forever. I'd just rather keep it as negative 7 divided by 3. If I plug in that 3, what it's going to give me is, I'm going to take that 3 and go 3 minus 6, get negative 3. And negative 3 divided by 3 is negative 1. Next, we'll plug in that 7. Of course, last we'll plug in that 10. All right, we're plugging in that 7. We have 7 minus 6, which is 1. And 1 divided by 3. Well, 1 divided by 3 is 0.333. So I'd rather just keep it written as 1 over 3. And last one. 10 minus 6 is 4. And 4 divided by 3, once again, just better keep it as 4 over 3. So, looks like my domain, if I gave myself enough room. Once again, let's write it from least to greatest order. It's kind of already written like that on my chart. So we got negative 4, negative 7 over 3, negative 1, 1/3, and last 4 over 3. Okay. It's your choice. You can plug them in into this original function and keep solving each and every time, or you can go ahead and change that function and just input it from there. Okay, next one. It says the student council sent its members on 4 field trips during the school year. The number of buses needed to transport the members on each trip is a function of the number of members who went on a trip. So the buses are dependent. So the buses depend on the members. So my members are my x values, are my domains, and my buses are my dependent or my range values, aka my y's. So the function consists of only the order pairs 52, 3. So for 3 buses, or for 52 members, I need 3 buses. For 72 members, I need 4. So hence 72, 4. Then we got 86, 5, and 105, 6. What is the domain for this situation? Well, once again, this is pretty easy. It gave me my points. Once again, our points are written as x, y format. So I just need to pick out the x values in each one of these points. So looks like I have 52, 72, 86, and 105. That's my domain members. Okay, pretty easy. Let's move on to the next one. This one's going to take a little bit longer, but just so you get a good explanation on everything. Mr. Plummer's unit quiz had 20 multiple choice problems. He awarded 5 points for each correct answer with no partial credit. So he gave no partial credit. It's very important. No partial credit. Just highlighting that real quick. It says identify the variables in the problem situation. What function model could be used to represent this situation? What are the domain and range of the function model? What are the domain and range of the problem situation? How do they compare? Does the problem situation represent a continuous or discrete function? Well, you may be able to answer a lot of these questions real quickly yourself, but let's go through them one by one. So once again, he had 20 multiple choice problems, and he awarded 5 points for each. So, in this case, it's clear that our problems, our independent variable, our x's, and our points are dependent because we get 5 points for each problem. So my points depend on how many problems I got right. So my points are my y's. So what's the function model? Bear with me here, guys. Alright, so the function model would look something like this. We would have y, or our total points, are equal to 5 times x, or the number of problems we got. So like, for example, we got 0 problems, we have 5 times 0, we get 0 points. If we had 1 problem right, we get 5 times 1, we get 5 points. If we got 10 problems right, we have 5 times 10, we get 50 points, and etc. Alright, what is the domain of the function model? Well, previously I told you guys, and this is what they're pretty much saying, the function model, they're just talking about the equation itself. And previously I told you guys, it's a linear equation without any restrictions, and right now we're just talking about the equation, so there are no restrictions. The domain would be x. It's an element of all the real numbers. Okay. Gotta get rid of that a little bit because I gotta look down. What is the range of the function model? Well, real quick, same thing. We're just looking at the equation, and since we're just looking at the equation, there's no restriction on it. And like I told you before, in a linear equation, it's just going to be y as an element of the real numbers. That one's pretty easy. I want to go and write that down for you guys. Y is an element of the real numbers. Once again, I know if you're thinking about the problem and how it read, there are some restrictions, but we're just talking about the function itself. Okay, and if we're just talking about the function, there's no restrictions. Let's remember that equation though real quick. Y equals 5x. I'm just going to write it here real quick. So what is the domain of the problem situation? All right, well now we're talking about the problem situation. Well, there's two different ways we can write this. I'm going to give them both to you. And I might run out of room writing it this other way. But the domain is the number of problems, or our problems, that we got correct. Okay, well, we can get 0 correct. We can get 1 correct. We can get 2 correct. We can get 3 correct, etc., 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 all the way up to 20. And I'm just doing it this way because I'm going to run out of room. I can't write 4, 5, 6, all the way up to 20. Okay, but I think you get the point. And notice how these are integers because I can't get half a problem correct because they said no partial credit. I can't get a third of the problem correct. So I either get 0, 1, 2, 3, etc. Well, another way to write this, and I like it better, is my domain is x is greater than or equal to 0. I'm sorry. Nope, messed that up a little bit. Let me rewrite that a little bit. We do have a restriction. It's not always just greater than 0. We have x is greater than or equal to 0 because I can't get 0 questions. But I have to stay less than or equal to 20 because 20 is the max amount of questions I can have. All right, so what is the range of the problem situation? Well, once again, it's dependent on our domain. So, once again, we can write a range. Once again, remember that function y equals 5x. Well, if we plugged in a 0, we get 5 times 0, we get 0. Plugged in a 1, we get 5 times 1 is 5. Remember, this is the amount of points that we score. So we either get 0 points, 5 points. Next, of course, would be 10 points, 15, 20, and etc. All the way up to 20 questions. So 5 times 20 is 100. So we can get all the way up to 100 points. All right, the other way we can write this is the range. Oh, and I forgot to add on the domain. That is between those two numbers, where x is an element of the integers. Same thing with the range here. We can just write it as y. Of course, it's greater than or equal to 0 because 0 is the least amount of points we can get, but less than or equal to 100. And once again, y has to be an element of the integers. We cannot have like half a point or anything like that. For example, I can't have 97.5 points, so I've got to say that they're all integers. Okay, well, looking at that, we're going to answer, how do they compare? Well, we kind of just talked about that. One's kind of like continuous because we can go from 0 to 20 continuously. The other one is not as discrete. So that's how they compare. So clearly our problem situation, if we're answering is it discrete or continuous, it's clearly discrete. All right, guys, a couple more problems. I just want to explain some things. All right, I want to look at number 2 real quick. Asks, what is the domain and range of the line segment? Well, and this one has verbal description. So once again, to find the domain, we go furthest left we can go, which looks like it's at -6 because we're looking at this point at the very left. And it goes as far as the furthest left it goes is -6. And the furthest right that this line goes is all the way to this right point right here where it's solid. And it goes to 3. So we're between -6 and 3, where we can be 3 but not -6. So clearly we're not all real numbers, what A implies. B says all real numbers greater than -6, which we are, and less than 3. Well, that's true, we are between -6 and 3. The problem with this guy is it's saying that we cannot be 3, so he's not correct. All real numbers greater than -6 and less than or equal to 3. That is correct. We are between -6 and 3, and we can be 3. All real numbers greater than -8 and less than or equal to 9. Well, that one's just way off. Alright, just so I can go over the range real quick. Our range is furthest down and up we go. So the furthest down, that's this furthest right point over here with the solid one. And the furthest down we go is -8. And then we go all the way up over here to 9. So we're between -8 and 9, and we can be -8. So the range does check out here. All real numbers greater than or equal to -8 and less than 9. Alright guys, I promise I won't go through all these problems, but I just want to pick out a few. We'll look at number 9. It says Jackie's grandfather gave her $250 for her birthday. To make her birthday money last, Jackie asked her mother to save it for her and only give her a $10 bill each Monday. So, the function AFT, which stands for the amount, is equal to 250 minus 10t, which makes sense. The total amount is equal to her initial amount, $250, minus the $10 she takes out each, I believe, week, right? Is what we read. Or every Monday, each Monday, so each week. That's what T stands for. Can be used to represent the amount of money remaining each week as a function of the number of weeks elapsed since she gave the money to her mother to manage. Which of the following is an appropriate description of the domain and range of the problem? Well, let's see here. It's pretty easy to find our range because our range has to be between 250, her original amount, and we're losing $10 each time. So it's going to go, of course, decrease all the way until we get to 0. After we get to 0, I'm assuming, well, her money's gone, and I'm assuming her mom's not going to give her like a loan. So we're not going to deal with negative numbers here. So our range is between the lowest amount, which is 0, and goes all the way up to 250. And of course, it has to be an element of the integers and go by multiples of 10, because that's what we're always going down by. 250 minus 10 for the first week, 240. Then we go down to 230, then 220, and etc. So let's find the range that looks most like that. So A has a range where it says the amount is greater than or equal to 0, but less than 25. No, our highest amount is $250, so A cannot be it. You know what, guys, I'm going to go ahead and do this real quick. Okay, so we decide it's not A. B says our range is just an element of the real numbers. Well, that's not true. It can't be all real numbers because we're never less than 0. We're never greater than 250. C says our range is, well, the amount is greater than or equal to 0, but less than or equal to 250, where AFT is equal to 250 minus 10t. That makes sense. And range, it says the amount is greater than or equal to 0. Well, once again, that's not true because we have to stop. We cannot be like 260. So we don't completely go up forever. All right. Well, if we had to, we could figure out the weeks if we needed to. We know that we stop when the amount is 0. Well, how long does it take for the amount to get to 0? If we had to solve, I'm just doing it for an extra example if we ever have to do this. We would take the amount of 0 because that's when it stops. We have 250 minus 10t, and we just solve for t to find pretty much our lowest domain. I'm sorry. Actually, our highest domain member, because our lowest, of course, is 0 weeks passing by. So real quick to solve, we'll get rid of that 250 by subtracting it from both sides. So we have 0 minus 250, so negative 250 equals a negative 10t. Get rid of that negative 10 by dividing it out. Well, negative divided by negative is a positive, and 250 divided by 10 is 25, so we got 25 equals t. So after 25 weeks, you'll have $0. Hence, once again, that's why I put a 0 here for the $0. So our domain, of course, is the time is between greater than or equal to 0 weeks, but less than or equal to 25. And t, of course, is an element of the integers because 1, 2, 3, 4, 5, etc. Alright, guys. Moving along. Number 11. The amount of fuel remaining in the gasoline tank of an SUV is a function of the number of hours h that the SUV has been driven at 65 miles per hour. This relationship can be expressed by the function below. F of h equals 40 minus 6 over 2/3 h. Which inequalities can be used to represent the domain and range of the problem situation? Well, let's talk about the function real quick. So, F of h stands for the amount of fuel left. And it depends on how long we've been driving. Okay, that's the h. Okay, well, it's showing 40 minus 6 and 2/3 h. So, I'm guessing we're losing, or I know by the function we're losing 6 and 2/3 of a gallon each hour that passes. Okay, so clearly we start with 40 gallons. And of course, we're going to start with 40 gallons, and of course, we're going to keep going until we're at empty. And then we're going to stop. So we're in between 0 and 40. And that, of course, will be my range for the amount of fuel. 0 gallons all the way up to 40 gallons. So look at our answer choices real quick. For range, our gallons are greater than or equal to 0 and less than or equal to 40, where f of h is an element of the whole numbers. I don't say it has to be whole. I think we can have 2/3 of a gallon and so forth, so it can't be that one. We'll have the number of gallons are between 0 but less than 40. Only problem I have with that is we do have 40 gallons, so we can be equal to 40. And we can have 0 gallons, so we can be equal to 0, so it's not that guy. We have the gallons are greater than or equal to 0 or less than or equal to 6. Well, I agree with the 0 part, but the 6, we clearly had 40 gallons to start, so he's out. Or we have the number of gallons greater than or equal to 0, but less than or equal to 40. That would be correct. And once again, if we had to solve for our domain member, for how many hours until we run out of gas, well, we run out of gas, our range member would be 0. We have 40 minus 6 and 2/3 h. So once again, just solve for h. Subtracting 40 over. So negative 40 equals negative 6 and 2/3. And of course, divide out that negative 6 and 2/3. And we find that we get, well, I'm going to double check it with my calculator and make sure that it's accurate. And yes, we do get 6. So 6 equals the hours, or hours equals 6. So after 6 hours, we'll run out of gas. And once again, our domain member can be like half an hour or a third of an hour or even a tenth of an hour. So we can be all these real numbers. So it does make sense that our hours are greater than or equal to 0, but less than or equal to 6. Okay, next one. I wanted to look at number 13. It's pretty easy though. It says, Eric earns $7.50 per hour working at a grocery store. One second. I'm going to do this. The total amount of money he earns on a given day is a function of how many hours he works that day. If he typically works between 1 and 5 hours each day, which is a reasonable range for this function? Well, of course, our function would read amount or y, depending on what you want to call it. In this case, I'll call it my amount because that's money. It's equal to, well, my rate of pay is $7.50 times the hours that I work. Well, I typically work between 1 and 5 hours. And it seems like they're saying I work 1 hour, 2 hours, 3 hours, 4 hours, or 5 hours, and no time in between. But since the way they're wording this problem, we can clearly see our hours is our domain members, because our amount depends on how many hours we worked. So we're looking for our range, our amounts. So if I worked 1 hour, I'd make $7.50. Okay, well, I don't see a $7.50 here or here. Do you see it here? If I work 2 hours, we'll take $7.50 times 2. We get 15. If I work 3 hours, I'm $22.50. If I worked 4 hours, $30. If I worked 5 hours, $37.50. Okay, well, both C and D look good so far. D would be incorrect because that's assuming 6 hours. And once again, the problem told me 1 to 5 hours. So our domain is restricted to 5. So C is our answer. Okay. It's the last problem I want to go over, guys, just so we can talk about it. Raymond, let me go ahead and do this real quick. Sorry. Bear with me. Raymond cut out a square from a piece of construction paper. The area of the square was greater than 25 square centimeters and less than 100 square centimeters. Which of the following best describes X, the length in centimeters of a side of the square? Well, let's talk about the area of a square. So to find the area of a square, area is equal to, well, side squared. Okay, so our range is what we're given. We're given ranges of 25 and 100, or we're told pretty much that our range our area is greater than or equal to 25. Tells us that was greater than 25. So 25 is the least amount that we can have. But it's less than or equal to, well, 100. Okay. Well, since the least amount we can have, or the least amount our area can be is 25, we can solve by just putting 25 equals S squared and think, well, what number times itself gives you 25? Well, if you came up with the answer 5, you'd be correct, because 5 times 5 is 25. So that's the smallest our side could be. And once again, side is our dependent, because depending on the side is how big our area is. Well, let's find the biggest. Well, 100 equals S squared. So once again, what's the number times itself to get you 100? Well, if you said 10, you'd be correct. So our domain is clearly between 5 and 10, and we can be 5 or 10. Or our side, in this case, our side is between 5 and 10. I'm sorry. The area of the square was greater than. Okay, so it's greater than, so we're not equal to at all. My fault, guys. I didn't completely read it. So we have to be greater than, we're not equal to it. And we're not equal to 100. We're less than 100. So our side would have to be greater than 5, but less than 10. Okay, that one follows with B. All right, guys. Well, that's the lesson for the day. Hopefully you learned something. And I hope to see you guys soon.